Right, some important information on lossless and lossy formats. Here we are, lossless compression, lossy compression. Basically, compression is a way to take a normal file size and munch that down to something smaller. So think about it for an instance. If you've got this graphic, then there has to be a binary equivalent for every single one of those pixels that you have in that graphic. And that can be very, very large. What we can do instead is compress it. Now, how would you compress a binary file? Well, that requires some other data representation. An easy way to put it is, let's take a text file and you just type out this Word document. And we can look in that file and we can take a look and say, every time we see the word "and," that's going to be X many bits, right? A and D. Every time we see that, why not have a table at the top of this thing that says A equals "and"? And then what we can do is everywhere we see "and," we can just replace it with an A. Now, that's a simplistic view of what file compression does, but it does do that. So that way, we just doing that, just the word "and," we can decrease the size of that file. We need to have the key. We need to know that when it hits A, it equals "and." And we can do that for every word that's commonly used within there, and it's massively decrease the amount of space that a Word file takes up. That used to be like a big thing because we did not have the storage space available. So we don't really use it that way anymore, except for when we zip up files or we put them in a compressed folder, as they're called. And lots of times that's just an easy way to get a bunch of files to somebody. But it does compress it because, well, we're going to send it across the internet. And if it's a smaller file, it will get there quicker. As long as we have that key. If we lose that key to what equals what, ooh, we're in big trouble. Well, in today's tech-rich world, in this information, what we are looking at is a lossless compression and a lossy compression. What it means is, if I take the standard picture with my camera, this is important information for anybody that cares about quality. So is that you? Anyway, lots of people will say, well, their pictures as JPEGs, JPGs. It's a very old format. It's very standard. So yeah, we can do that, but it's lossy. In other words, the compression algorithm that slightly alters the data, make it easier to store, takes advantage of the limitations of human sight and hearing, and is usually used for images and videos. And common lossy files include JPEGs, MP3s, and MP4s. What it means is they didn't explain this, but if you take that picture and it's actually the information in that picture is this big, and then you make it a JPEG, you can never go back and get the other information. It's lost. You cannot recoup it. You cannot get it back. So you take that picture and it's this big, it's got all this data in it about colors and saturation and all that stuff. And you say, I'll send that as a JPEG to my grandma. And that's the way the photo is going to be forever. It can never get that information back. Maybe you don't care, right? No big deal. Well, a lossless compression, that's a compression algorithm that does not affect the original data. In other words, the uncompressed file will be exactly the same as the file before. So in other words, we still need to get this information as quick as we can to someplace. So let's smash it down further. And if we make it a GIF, which only has usually very little colors, so you wouldn't save any image as a GIF unless you want to, make it so it's animated. Or let's say PNG, this is a portable network graphic file. And that is the way we want to do it now. I would never save a file as a JPEG. I would save them as a PNG. And there are others in here, like TIFFs are that way too. And then that way it's compressing it. But if we want to get the original information out so we can convert it, for instance, to a TIFF, no problem. All the information is there to convert it. if I take this JPEG and say, now I'm going to convert it over to this TIFF format, that information was gone and I cannot get that back. So these days you should use a lossless compression, and PNGs are that for pictures, and stay away from the JPEGs. Again, for music, right, there's a lot of different standards out there for music. MP3s are the old standard, which you shouldn't use because whatever audio was part of that is gone when you make it an MP3. So a common lossless compression algorithm is run length encoding. Instead of storing each individual bit in the file, it stores how many of each of the bits appears in the sequence. That's cool. For example, instead of storing 30 zeros in a row, it would just store the number 30 followed by a 0. So in other words, using that technique I was talking about, that way it's like, hey, we're taking up a whole lot less space to actually, record this. And then sometimes you do get compression artifacts when it's compressed to very small size. They'll have a lot less visible detail than the rest of the image and the compression. Let's also take a look at digital images formats. I think the file images. There's your JPEG. There's a PNG. And again, you could size this. So originally, if they made the PNG of test out this huge, you could size that out to that size and you're okay. Where if this was a JPG, if you move beyond the resolution it's saved at, it loses that quality. That's a good example. Animated GIFs, there you go. TIFF. TIFFs are used. That is it for digital media.